Today's lesson is on points, lines, and planes. And let's write ourselves an essential question. I think that question might be, how can we use symbols or symbology to talk about geometric figures more efficiently, and write about them also, but that'll be good enough for now. All right, so how are we going to do that? Well, let's just start going through these notes. First, we're going to talk about a point. And guys, this space over here, all this to the left of your notes, I want you to use that space to write down questions that you might want to ask me in the next class, or write down things that you think you need to highlight for yourself. Anything that you want to use that space for to help yourself, then by all means do that. But it is an excellent space for you to jot down questions that you'd like to ask next class. All right, so a point has no dimension, and a point is always named with a capital letter. So, for example, if we have the point and it's P, then the way we would say that is point P. All right. What is it that extends in one dimension? That would be a line, right? A line goes forever. It's one-dimensional, goes forever in two directions, and it's named with two capital letters. Although sometimes you'll see a line, we'll see a lot of this, and it'll be named with a lowercase script letter, but usually, I'll say usually, you'll see it named with two capital letters. So for instance, the symbol for a line would be like this, and if we wanted to talk about line AB, then that's how we would denote that there. That is line AB. All right, you got to have the symbol on top, and you got to have arrows on both ends so that everybody knows we're talking about a line. What is it that extends in two dimensions? Okay, well that would be a plane. A plane is two-dimensional. It's usually represented by a shape that looks like a parallelogram. And even though we're going to talk a lot about parallelograms later in the year, I think you all already know what a basic parallelogram looks like. And it can also be named with a capital letter. Sometimes, though, you will see a plane named with three letters. So we could call this plane P, or if we have point A and we have point B and we have point C, we could name this plane P. We could mark it like this, plane P, or we could call it plane A, B, C. All right. The 3 points that we used here, just remember, we'll talk more about this much later. The 3 letters that we use, these 3 points have to be non-collinear. What does that mean? Not on the same line. Non-collinear. And don't worry, we'll talk more about this in a little bit. Points that lie on the same plane are called collinear points. So if I talk about collinear points, I'm sorry. We're not talking about collinear. We're talking about coplanar. If they lie on the same plane, they're coplanar points. And that's like ABC in my example that I gave you here. Okay, let's just draw another one here. If I have Q, R, S, and then let's say T was down here somewhere. Of course, T is not on the same plane with Q, R, and S, but we know that points, we'll pick 2 of these, Q and S are coplanar. And what else would Q and S have to be? They would have to be on the same line, which is collinear. All right, if I pick any 2 points on that plane, then they will also be collinear. Collinear points are on the same line. So let's look at a little example. If I just draw a line here, and I have A, B, C. Let's say I got point D down here. Clearly it is non-collinear with the other 3 points, but I can pick any 2 of these points. Points A and B are collinear. Points B and C are collinear. Points A and C are collinear. And how about D? Is it collinear with A, B, and C? No. How about D? Is it collinear with point C? Well, sure, because I could draw this line right here, right? Any 2 points, remember, any 2 points will define a line. Any 3 points will define a plane. So if I ask you if points B, C, and D are coplanar, yes, they are coplanar because any 3 points define a plane. B, C, and D, however, are not collinear. All right, you got to remember that. Any 3 points can make a plane. Part of a line that consists of 2 points called endpoints, and all the points on the line in between the endpoints. That is a what? You know this. That's a line segment. And we also name a line segment with 2 capital letters. And the symbol, if I want to talk about segment AB, for instance, I just put this bar over the top of the 2 capital letters. Guys, be aware, I do not have the endpoints. You do not put the endpoints in this symbol for segment AB. It's a segment without the endpoints. So the way we would read this is line segment AB. All right. What about part of a line that consists of a point and all points on the line that extend in one direction? Sorry about that, I had an interruption. Part of a line that consists of a point, and in this instance we're going to call this an end, no sorry, not an end point, an initial point. An initial point because, surprise, surprise, we're talking about array here. Initial point, and all points on the line that extend in one direction. An array is also named with 2 capital letters. So I guess the moral of the story is, when in doubt, call something 2 capital letters, right? Don't do that with a plane though. Okay, and the symbol for array is like this. Actually, we don't put the little point on the end of the ray either. All right, so this would be ray AB, and we would say it like this, ray AB. And what you have to be very careful about here is, remember that the first point I name, point A, is the initial point of the ray. So here's A, and B is somewhere over here. So guys, this would not be the same thing as ray BA. There is no ray BA in this picture. This has to be called ray AB, with A being the initial point. Okay, let me put another one over here. Let's see, L, M, N. Okay, if I want to talk about ray LN, then ray LN is right here in red, right? All right. So that's ray LN. Okay, if I want to talk about ray MN, then I've got to highlight this right here. All right, there's ray MN. 2 different rays. MN is part of LN, But ray MN and ray LN are not the same because they do not have the same initial point. Be careful about your symbols. All right, if C is between A and B, and it's on, and this is a line here. It's kind of hard to see. If C is between A and B on line AB, then ray CA and ray CB are, well, I don't know. I have to draw this. Always draw yourself a figure in geometry. So here's A, here's B, and they're telling me that C is between, then ray CA, here's ray CA, there's ray CA, and ray CB, what are those two called? They have the same initial point, but they're going in opposite directions. Those are called opposite rays. Okay, so opposite rays have the same initial point. In this case, they both have the initial point of C, but they go in opposite directions. So would ray BA, think about this and tell me what the answer is tomorrow. Would ray BA and ray AB be opposite rays? I'm going to write you that question. Would BA and AB be opposite rays? In this example right here, you tell me, yes or no. All right, two or more geometric figures intersect if they have one or more points in common. Example, well, let's just take a line and a ray. All right, here's my point in common. They intersect. All right, you can have intersecting figures, you can have intersecting lines, rays, not intersecting points because they don't extend in any direction. They're one-dimensional. The blank of two or more geometric figures is the set of points the figures have in common. The intersection, and just to remind you, I know you learned this. This is the way we denote intersection in geometry, remember? The intersection of two or more figures is the set of points that the figures have in common. What are some examples? Well, let's take line AB here, and let's take line EF, and let's take line CD. Okay, what are the points of intersection? Well, there's a point of intersection, there's a point of intersection. Here's a point of intersection, but it's not the intersection of all three, right? I need the points of intersection of all three. So the intersection of these three lines is actually, well, and I didn't label these points. Let's label them X and Y. This one here, R, is not the intersection of all three lines, so we're not going to include it. We're going to say points X and Y are the intersection of all three of those lines we have there. All right, be sure, remember to be jotting down any questions you might want to ask in class. All right, let's look at these examples here. Name 3 points that are collinear. Well, that means they got to be on the same line, right? So I can see that D, A, and C, D, A, and C, and these are all points, of course, point D, point A, point C. Those are all on this line right here. Name 3 points that are coplanar. Well, I can see that A, B, C, and D are coplanar, but remember, I can pick any 3 of those points that are not collinear, and they could be coplanar, but I'm going to pick the ones that actually look like they're on the same plane. So how about A, B, and C? Point A, B, and C. They're all on that gray plane that you see there. Name 4 points that are not coplanar. Okay, well, let's see. Since A, B, and C are coplanar, then I can see that E is the one that is not on the same plane with those 3 points. Here's a question for you. Would points A, C, and E be coplanar? Think about that. Would points A, E, and C, are they coplanar? Yes, they are. Even though you don't see the little plane shaded in there, we know that any 3 points make a plane, so those 3 points are coplanar. Any 3 points that are not collinear are coplanar. All right, how about this little prism here? Name 3 points in the diagram that are not collinear. Okay, well, A and B are collinear, so let's just pick one that's not on the same line with those. How about C? And there's a whole bunch of answers you could come up with there. All right, name the point in the diagram that is coplanar with points A, D, and E. Here's A, D, and E. So clearly, here's my plane that contains those 3 points. So the other point that's on that plane in the picture would be point H, right down there. All right, let's draw 4. You know what? Let me look at this here for a minute. I think this would be good. This would be a great place for you to pause your video and try to work out the rest of these examples on your own. While you're paused and you're doing them, I'm going to put the answers up here, and then I will start the video again so you can check your answers. So take a pause, try to work out the rest of this page, and then I'll be back with you. All right, so you've worked all your problems that I asked you to do here. Draw 4 non-collinear points, label them A, B, C, and D. You can see where I did that here, A, B, C, and D. And then draw line segment AB. You see I did that there in red. Ray BC, initial point has to be B with the arrow going through C. I did that in green. Line CD, I did that in black, extends in both directions infinitely. And then ray DA. So you can see I did that in purple. The initial point is at D, and the ray extends forever and ever through point A. All right, so hopefully you got something like that. The next was to draw points A, B, and C so that they are not collinear. Of course, any 2 of them are collinear because any 2 points make a line. Then draw line segment AC, ray BA, and line BC. So I tried to use the same color conventions that I did previously. Check your answer there. The next one says draw a line, label 3 points on the line. I picked QRS. You can pick any 3 you want. The opposite rays are RQ and RS. You have to have the same initial point to have opposite rays. You could not have QS and SQ being opposite rays. You've got to know what opposite rays are. Commonly missed concept. Okay, and then finally, sketch 2 lines that do not intersect. I sketched the 2 blue lines. I probably should have labeled them, but I didn't. The 2 blue lines are the ones that do not intersect. The only way I can get non-intersecting lines is to make parallel lines, which would be coplanar, or skew lines, and those are 2 lines that are in different planes. So I drew parallel lines. So that means they're in the same plane. The blue line, sketch a line that intersects each of the other 2 lines. That would be line AB there in red, and label the points of intersection. I labeled them A and B. You could label them whatever you want to. All right, then we were asked to sketch 2 planes that do not intersect. Here are my 2 planes. Plane, I didn't name them, but they're green and they're parallel. That's the only 2 kind of planes you're going to have that don't intersect, is if they're parallel. Sketch a line that intersects both planes. I did that in blue, and what my intention was for this line to be coming up under the bottom of each one of the planes. So it comes up through the bottom and out the top of this plane, and then it comes up through the bottom and out the top of that plane. So that was my line that intersects both planes, and I labeled the points of intersection R and Q, and again, you could label them whatever you wanted to. And then finally it says sketch two planes that do intersect, and here is my drawing of that. Not a great drawing. Your textbook has a lot better drawings of intersecting planes. I'm not too good with that. But anyway, the dashed one and the not dashed one, the blue planes, are supposed to be my intersecting planes. And it says label the blank of intersection. Well, the whole point I'm trying to get to here is that any time two planes intersect, the intersection will always be a line. You have to remember that. Intersection of two planes will always be a line. Okay, and finally, at the end of every lesson, what I want you to do is write a little summary. It will help you when you're studying and trying to remember, if you need a quick look back. So I'm going to write one summary with you, and all the other days you will need to write your own summary. If I check your work and you don't write a summary, your lesson will be incomplete and you will lose points for that. So what did I learn? And I don't always have to write sentences. I learned definitions of point, line, plane, what else? Ray, segment, collinear, coplanar. So I might not catch them all, but those are intersection, and opposite rays. So see, if I have all this jotted down here, then if I'm looking for something, I can quickly say, it's in that lesson. And I learned that intersection, and I'm going to use the symbol for intersection of two planes. I'm just going to hit the highlights here, guys. Intersection of two planes, always a line. Oh, another biggie. Any three non-collinear points define a plane. And finally, any 2 points define a line. Okay, now there may have been a few other things you learned, hopefully, but this is a summary. Your summary is up to you, but I do want you to make a habit, start right now, of writing yourself a good summary at the end of every lesson. It's very important, trust me. All right, thank you.